Cool.
So Gaurang, all the audience can see you. They will ask questions over mic and you will be able to hear them.
Awesome.
Okay.
Hey, hi team. Myself Gaurang. I'll just give a brief intro about myself. I'm working as a solutions architect in Cast AI. Cast AI is a platform which optimizes your Kubernetes spend. They have written their own autoscaler, which basically takes insights from AI engine, heuristic engines. There are graph engines. So we have multiple engines. So the engines basically give advice and the autoscaler acts on it. And based on that, we actually identified that what is the problem. And today's topic is basically to understand how can we bring efficiency in the DevOps work, right? Especially optimizing your Kubernetes cost. Right? So before we start, let's understand what is the scale of the problem, right? The scale of the problem is massive. We did analysis and Gartner come with a statement that half of your cloud cost actually is wasted, right? Especially the compute cost. So whatever you're paying to the cloud provider in terms of compute, almost half of them is wasted as per the Gartner statement, right? We also have found out that Datadog also released one statement that whatever the applications you are provisioning in your Kubernetes cluster, half of your application are using only 30% of their CPU resources, right? So that is what the generic look right look like. Uh, then what is the scale of the problem? Almost the problem is of about $305 billion. And it is getting more expensive as Google recently announced that they're going to increase the price, right? So Google is getting more expensive and the problem is going to be more serious. And a lot of the people and a lot of the companies are actually going further in optimizing journey, right? So let's understand the next step of the problem that first we understand that the massive scale is $300 or $300 billion, but it is not stopping there, right? The problem is very complex and it is more worse than what we think. So we started to analyze the problem. And the first thing what you do is you try to understand that what is your Kubernetes cost. To understand your Kubernetes cost, you go to your AWS bill and try to figure out what's your bill look like, right? And it's very, very complex. You have your AWS bill. It went up every month by month, and you start sketching your head why it is going month by month. But what I'm trying to say, it is not your fault. It is by design because the bill is very, very complicated. You have line items in the bills. The line items are by region. Every region have some compute cost, some data cost, some network cost, but ultimately you will not able to understand it, what it relates to your actual real-time usage, right? How much your application cost, how much your product cost, and that is there's no direct correlation. It's just that it tells you that how much you have provision in the infra, right? And it's very complicated. So it's very, very easy. Next is once we understand the problem, right? The next thing what we do is let's try to solve the problem line item, right? And when you list down your bill, you understand that the maximum bill or maximum line item you are paying to is your compute cost. So your EC2 cost, your VM cost is the maximum line item, right? So let's then you try to understand that okay, this is my line item cost. Why not I try to solve this problem, right? And the first thing you do is you try to find that what are the alternate options you have in terms of finding the cheaper instances, right? And you have basically three items. One is on-demand node, which you are paying for 100%. Second thing what comes is reserve instance. So you reserve for 1 year, 3 year savings plan, and then cloud provider provide you a discount of 40%, 50%, 60%, depending on the demand. So most likely you end up at 60%, right? But you see, the maximum saving you achieve is by spot, right? And once you see that, you started reacting like, oh, spot is the cheapest one, and you start using the spot. But it is not the actual case, right? You see the price today, and when you start using it, the price changes, right? And that's what actually comes out that you started with X amount, you started using it, and the next day or next week, the prices have changed you assume that you have 90% cheaper, but they come to 80% cheaper, sometimes 70% cheaper, sometimes 60% cheaper. The prices are keep on varying. So it's again very complicated. So it is not guarantee you that you're gonna save almost 90%, right? So that's the spot problem. On demand, you always know that it is the same price, so no problem, right? So then since we have data and we manage lots of cluster, so we started gathering data and we tried to understand how much the spot prices have increased, right? So we aggregated the data and found out that on a cloud base, Azure has increased, or in Azure, spot prices have increased almost by 108%. Right? GCP, AWS and GCP were almost same. GCP is outlier, it is decreased, but yeah, most likely it's almost same. Then we started thinking, okay, is the region-wise data is indicating something? So we started getting the data region-wise, and pattern is almost same. Every region has increased the data, spot prices, right? Uh, Germany being the worst is 150% spot price increase. Uh, then we started looking at the family-wise. This is the family-wise data in AWS prices, right? So everywhere the prices have increased. So indication is spot prices are increasing. It is not guaranteed to give you 90% change. So, okay, this is one dimension of the problem. Let's understand the next dimension of the problem. Uh, when you try to go inside the Kubernetes space, right, this particular problem become more and more complicated. The optimization problem, right? So the very first problem is how to utilize your node efficiently. So you have, let's suppose for simplicity's sake, I kept 3 nodes here, and every pod is having different sizes. So how would you get the maximum utilization of the pod? If you see here, the node 0 is being utilized the most, and node 1 is utilized the less, right? It's like solving a jigsaw problem. So you try to find the best suited node for a best suited node family, right? And get it adjusted. But it is way more difficult and way more complicated for a human to solve this problem, right? Most likely in jigsaw problem. So what you do basically, if let's suppose the scale of your cluster goes from 3 instance to 1000 instance, give an example, right? You will not be able to solve it. So that's how our reaction would be, right? Uh, so let's understand next. So the third dimension of the problem is the pod itself, right? So you request 2 CPU, let's example, for a pod level, but the usage is almost 1.8, 1.9. That's what you understand while deciding the 2 CPU. But in the real time, when you deploy the application, this is your real usage comes out. So massively over provisioned requested and very underutilized usage. So that is the third dimension of the problem, right? First is the build complicated. Second is the node utilization is not fairly done, and third is the pod itself is requesting more CPUs and utilization is very less, right? This is a real example. We got it from one of the clusters what we were handling. Is they're requesting 30 CPU and 57 gig of RAM, but the real utilization is only 3 CPU and 46 gig of RAM, right? Which means that at the memory side they are optimized, but at the CPU side they are not. And it can be vice versa also, that sometimes you are optimizing CPU side and not memory side. So how would a developer or a DevOps engineer optimize it at the pod level itself, right? That's the next problem we need to answer, and we have to solve all these problems in all 3 dimensions. Then only we can get to an optimal state or and reduce your waste. So that's the problem, and that's the level of problem we are dealing with, right, in the Kubernetes space. Then what is the result? Lots of compute are waste in terms of node being low utilized, in terms of request being higher, pod being low utilized, in terms of the spot prices and what to choose, what type of node to choose when. So ultimately, the end result of that is lots of CPUs is actually wasted, right? Uh, this is a graph we captured, and this is basically a real-time graph for any of your application which is customer facing, and the utilization. So let me explain the dimension of the graph. So the yellow line is basically what your requesting CPU is, or what your application is asking for. And you see in the morning time it's very low. In the daytime, when the day starts, you started using more. Afternoon it goes down. and then again it goes up, and then in the night time again it goes down, right? That's the general pattern of any applications which are used, which are customer facing, which are having a pattern, right? But what your autoscaler is provisioning is the blue line. So it is provisioning so many CPUs. So you have timeline and CPU utilization is with the yellow is the real utilization, and the blue is basically is your autoscalers or traditional autoscalers are provisioning, right? What is happening here? We are using the yellow line, but we are paying for the blue line, and the gap is basically what your waste, what's your compute waste you're paying extra to the cloud provider, but you're not using it, right? Meanwhile, I want to stop here. Any questions you guys have regarding any statement I did here? Okay, cool. So let me proceed. One of ML training job which we analyzed in one of the customers, right, had the same problem. Uh, the training start at 10 o'clock. Once the training start, the application start massively requests, so it went up to almost 3 to 4,000 CPUs. So the autoscaler provision 4,000 something CPU, the application is asking for 3,000 plus CPU. That's okay. Sometimes autoscalers ask and generate more capacity, but it stays at the same level, right? The application started using and going down, but your provision went down very, very late. So almost 40-50 minute late response. And the same happened here, which is a very, very huge delay in the response in terms of downscaling, right? What is the result? The result in this graph is we wasted 6,000 CPUs for 4 hours. That's the waste we generated in this particular graph, right? Uh, then let's understand what is the average waste across the cloud providers. So we have data, we have customers in across cloud providers. So we get out the data and we start to understand what is the average waste we are generating, right? So on an average, 37% is the waste, cloud expense waste is basically is, is allocated and is not used. So you are wasting 37% resources. Then we try to categorize between the cloud provider, and the story is same. Most likely, lots of startups are using AWS, so you have a little bit here because startup at the start of the journey, they are little less cautious about the cost. They are going for hyper growth, and then they started looking for the cost optimization. But GCP and Azure are mostly more optimized, but the gap is very, very low. The next we tried is what is the impact we are bringing in. So what we did basically is we just changed the instance type. We picked only the correct instance for them, and just picking the right type of instance for them has resulted into the 9% savings in their bill. The impact only to decide which machine they use, right? Uh, Also, how much is the overspending? Almost 2.45% on an average they are overspending on the cloud. Uh, and I'm talking about node over provisioning, resource over provisioning, everything included. So right, so that's the overspending they are doing as of now, and that's the average number what we got it for all of the scales what we analyzed, right? But honestly, the problem should not be this way, right? So what we did basically, we developed an engine. We developed an AI engine, and we asked him to optimize, right? And most of the AI engine or most of the product can optimize it, right? But the question is, with automation is what the key, right? We don't want to give you the consultation and then do it, let it do it by yourself, right? So we started ask the AI engine to optimize with automation. We don't want to do ourselves. And what is the result, right? So let's understand the results. So this is a real-time example. One of our customer, which is in social media and news media, they have lots of documents, the online documents, right? And they process those documents and try to understand the insights from that document, right? And try to find the narrative out of it. So for that, they use machine learning, right? So this is the job they ran, right? Before us. So they started the job here, went up, job started finishing up, and gradually going down. But the autoscaler or typical autoscaler is not going and not responsive at that space, and they kept it very high CPU long for almost 4 hours and went down suddenly, right? So result of this basically is the they are let's suppose they are using 30% efficient. It means they are provisioning 100 CPU, they're only using 30 CPU. So 70 CPU they wasted. And the waste here basically is 10,000 CPUs for 4 hours. So that's the waste they generated to train the job, right? And this is what the next result, what we developed after applying the automation, right? The efficiency of in this matter is almost 89%. Let me move to the next example, right? Again, the same, this particular job ran for 9 days, right? The scale of the job is almost 2000 CPUs, right? So they started on this. The yellow line is going down. As jobs are completing, they are basically going down. The pods are deleting themselves, and at the same time, we are also deleting the capacity. Right? The same pattern here. You can see the waste is very low. So that's what we saved almost 70% in the cost here, because we went up from 30% to 89%, right? Utilization. What next? This is one more job and one more pattern they had. Again, the same pattern. Here, the job ran for 3 hours, almost 7,000 CPUs they used. And this is what we discussed, right? The normal pattern of the customers, what they had. We applied our engine on this also and try to understand what we got after results. And this is what we got in the after results. So the pattern and the utilization is almost following for the provision CPU, and the graph is very close, and we are highly optimized here. And once we have it, this is what we feel like. When we solve the problem, this is what we feel. Okay, so let's understand one more problem. So that was a social media company. So we started looking and try to get the example of some other companies. So we analyzed 1 million patient data of a pharmaceutical company, right? And what we achieve basically is this is what they were doing as of earlier to us. This is the model. They were using 0 spot nodes, 45 on-demand nodes, and the job ran for 1.2 hours, right? All the tasks are completed. It costed them around $200, right? When we started optimizing it, what we did basically is we moved some of their workload from on-demand to spot, right? So we picked 20 spot for them, 4 on-demand. Job ran almost the same time, little bit extra of 1 minute, but almost the same time. All the jobs are completed, but the cost, what incurred now is $52, right? And everything is automated. We basically, the engine decided to pick which type of node and which type of instance, everything, right? The result is basically 79% cost reduction. The cost reduction basically is the real-time utilization of that, right? So we actually reduced the waste. So I would say 79% of the waste we reduced in the cloud provider bill, right? So yeah, this is what we have, right? What do you think? So what I wanted to say is the problem is massive. We solved it with an engine and AI. If you think that you spend more, you can contact me. Probably we can basically discuss the problem. The idea which I wanted to tell you is the problem is complicated. You can solve it. It's not like human cannot solve it, but you cannot solve it continuously. It has to be some machine learning or some machine to do the job instead of a human doing it, right? That's it. If you have any questions, happy to answer.
Thank you so much, Gaurang. Let me share the camera so that you can view the audience.
Yeah.
I hope you are able to view.
Yep. I can see it.
Yeah. Does anyone have questions from Gaurang? Yeah.
How you are deploying this to any Kubernetes cluster? Are you deploying any service separate or a sidecar container?
It's a agent. We install agent, and we install multiple agents to do multiple tasks, right?
And for the cluster or it's across the cloud?
No, it's cluster wise. Yeah.
Cluster wise.
Yeah, because we have to understand what we do basically is we read the metadata of the cluster,
Mhm.
and the engine basically consume that data and try to analyze what should we do to optimize it, right? Either be change the machine type, instance family type. We recommend like you can go for spot or non-spot. That is also recommendation is there, and also handling the spot eviction, predicting spot eviction much in advance than cloud provider. All this part of the engine, right? And it decides what to do, when to add capacity, what not to add capacity. So all this being part of the job. Yeah.
Okay. And everything will be processed on the cluster, or it will be at
No,
your.
it's a SaaS model. So because the engine are very heavy in compute, they run machine learning algorithms. So we started running everything in the customer's cloud. The bill of that particular engine is too high. So we decided to go for SaaS.
Clients, like we can't share our data to other cloud.
No, it's metadata of the cluster, which means that what type of machines you are using, what type of workload you have. We do not read your config maps, secrets. We do not have permissions to read logs. We cannot do exec. So the agent will not have any permissions to look for any data, or maybe I would say application of business data. The data what we interested in is basically how many workloads you have, what are the pod count you have, what are the requests CPU, what is the utilized CPU, the real-time usage, right? All this what we require. That's it.
Okay. Yeah, that's.
Does it work for air-gapped environments?
Yeah, for air-gapped environments, what we have designed is customer hosted solution, which means that we deploy our mothership on customer account and then connect it internally. So that requires they have to bear the cost of the central server. That's it.
How do you handle the spot evictions in real time in case of air-gapped environments? You are not
Because
processing the data in the real time in that case.
so if your cluster, so the mothership is basically is connected with your cluster in your environment itself. Right? It's not going, so the signals are not going out of your cluster. So imagine that what we technically do is basically we create an account. Let me take an example of AWS, what we do. So we create an account inside customer's AWS account, deploy our central mothership completely there, and connect the agent with that central ship via VPC peering internally itself. So it's not going so the signals are not going out. It is going via the internal mothership. Mothership is still running in your account, so it try to solve all the problems and give instructions for spot eviction and everything.
And what is the footprint of that mothership?
Mm, depends what level of processing you want to do. As of now, whatever customers we have who wanted to have this mothership, they are processing almost 100K to 200K CPUs on daily basis. So in that case, our footprint is also probably around 4 to 5K. Yeah.
Okay, so you
Yeah.
said
So we have deployed this kind of solution for customers which are processing almost 100K CPU, 1 lakh to 2 lakh CPUs on an average daily. So if you're processing 1 lakh CPUs a day, the mothership also grows in size automatically.
do you
So
alter the requests and limits of the pod?
yes,
Have
yes, we can do it. Yeah.
do you do it, or do you just signal that that should be done?
We do it. Means everything is controlled by your team. Means customers are controlling this, right? But yeah, we can do it. We have capability to alter the request also at the pod level.
But don't you think that that is the purview of developers? How much resources
No.
should be allocated to
So
the
that is the problem we are trying to solve.
they know their applications better?
Not always the case. So developers generally run the applications and understand the CPU requirement in their environment, right? What is the requested CPU there, or what is the utilized CPU they're doing in test versus stage versus production? It cannot be the same, right? Every environment have their own CPU and this, right? So we ends up, we, as I said, right, I show the data. customers ended up having a very high resource request where instead of the utilization one. So what we do is simple, right? We look for the utilization pattern. We understand their previous 7 days, 8 days pattern, and based on that, we alter the pod request.
Right,
So
you do
if you
that, but let's say I've done a code change and that expects more CPU and memory.
yes,
Your agent won't know that. If a new release is made and based on the 7 days past utilization, you will right size my pods.
so every 30 minute we basically understand and check for the request, right? And if the utilization is going beyond a certain threshold which you defined, we increase the requested CPU also. It's just that we are not reducing it always. We are following your utilization curve, be it a node level or be it a pod level. So if you started using more CPUs, in next 30 minutes, I'm going to increase it.
Okay, and based on the graphs you showed in the earlier
Yeah.
slides, it seems that you are also evicting a lot of nodes, right?
Evicting pods, yeah.
Yeah, so evicting the pods.
Yes.
And do you, so many customers may not have relevant, let's say,
Yes.
pod disruption budget set. And in that case, how do you handle those kind of scenarios?
Yeah. So
The
so
pod
the
disruption
evict,
budgets?
you are totally right. Means I cannot name it, but very big companies are not have the applications capability to support eviction, right? Lots of companies have to migrate it. They follow the lift and shift pattern, right? They lift it from monolithic and put it instead of redesigning the microservice way. So yeah, your problem is correct. This is a live problem we face day in day out. So the way we did basically is we put a control over the eviction, right? So you can say that you do not touch application or do not touch a node which is running this application for eviction. Rest everything you can do it. So you means we give a control to the customer that they come to know, they tell us that application A, B, and C are not prone to evictions. If you restart them, we'll lose something. There's a problem. It will create problem to our environment. So we label them in a way that we do not touch those nodes where they are running.
And whose call is that to label them?
It's SRE and developers call.
So if you're not letting me right size or give required resources to my application, I'll just label it, do not touch it.
Yes,
In
yeah.
that case, that will not bring significant savings as you were.
Not always. So not all the applications are like this, right? So let's suppose 3 applications are not eviction friendly. You
Don't
label them.
decide what resources should I allocate to my application. I'll just say, don't touch it. So how do you tackle that sort of problem?
So so we have to find the right balance between stability versus cost saving, right? So if my 3 or 5 applications are not friendly with evictions, should I go for stability first or eviction first, right? So we do not touch them. We touch other 70% environment. So we optimize 70% environment. We do not optimize 30% environment, right? So that's the situation. It may be a 50% improvement, optimization, or 50% we are not touching. So at least we are giving you 50% optimization. That's what I'm trying to say, right?
So I can even configure my autoscaler to handle and do the evictions. In
Yes.
case, will Cast AI still be able to give me that sort of
Yeah.
cost?
I mean, it's always the question is who's doing better job.
So
Right.
if I optimize my cluster autoscaler well,
Mhm.
do I still need Cast AI?
Depends. So if you have a very constant pattern, your applications are not moving too much, you can do it with your autoscaler, no issues at all, right? But if you have a pattern like I showed you, right, it is going up and down day in, day out, the scale is massive, 2000, 3000, 4000 CPUs. At that time, it means we are better performed over there.
Okay, thank you.
Yeah, thank you.
More doubts? Anyone? I think we can wrap it up. Thank you so much.
Thank you for giving me time. Thank you so much. Yes, yeah.
And a huge rounds of applause for him.
Yeah. Thank you, guys.